In today's lesson, we are going to be looking at appreciation and depreciation. So these are two terms in finance that you are probably familiar with, at least in terms of what they mean. Maybe not the terms, the actual words themselves, but you'll probably understand or hopefully see clearly what these two terms represent and where you can see them in your everyday lives. Before we get into that, though, just kind of want to go through a little bit of a warm up. So which or would you choose, or what would you choose? You're looking at, so this is looking at renting a hotel room, a larger studio, one king with a sofa bed. You stay 2 nights and save 20%, includes breakfast for $151 a night. Or would you choose the staycation package, which includes a bottle of wine per stay and a $100 gift card for $189 per night? What would you choose? And again, with these, there's no right or wrong answer, just kind of getting an idea of just what your thoughts are behind it, what your reasoning behind it. So if you're doing this at home, just try to think about what would you choose and think about why would you choose that. Would you get gas around the corner, say like at a gas station, or would you drive further for cheaper gas and wait in line? Right. So some people only go to Costco to get gas because it tends to be cheaper, but there usually tends to be lineups as well. And obviously there's fewer Costcos than there are gas stations. So which one would you choose? Cell phone data plans. Would you choose the $80 per month, 5G access, 200 gigs of data? $90 a month, 5G access, 40 gigs of data? Or $95 a month, 5G net access and 60 gigs of data? So which one would you choose? Why would you choose it? Is there anything influencing that choice? What about Amazon Prime? Would you pay for it monthly, $8 a month? Or would you get the annual for $79 a year, which is equivalent to $6.58 per month? Which one would you choose? Toilet paper. Maybe not something that you're going out and buying, but you can just kind of look at the scenario. Or maybe think about which ones your parents would choose. Would you choose just the 24 single rolls for $9.89? Or would you choose, which is just 12 rolls? Or would you choose the 40 rolls for $20.99? And which one would you choose? Looking at the two treadmills. Would you buy the Nordic track that's on sale for 60% off for $12.99 or $1,299.99, or the Horizon treadmill for $999.99? Again, no right or wrong answer. What's your reasoning though? Why would you choose one over the other? Or what is your choice? Which one would you choose? 2022 Canyon, brand new, $51,000, or 2018 with 90,000 kilometers for $43,000? Again, which one would you choose? You choose an investment that's currently worth $10,000 and earns 1% interest each year? Or would you choose an investment currently worth $5,000 and earns 5% interest each year? Which one did you choose? May not know what the terms interest means. We will look at that kind of briefly, but just kind of based on your own, what you know already or what you think you know, or what the ideas you have around what interest means and things like that. Which one would you choose? Which bank account would you choose? Would you choose the Basic Plus bank account? So 25 free debit transactions per month, free Interact e-transfers for either $0 or $11.95. Might notice some fine print though. It's $0 if you have a minimum balance of $3,000 in the account for the entire month. If you don't have a minimum of $3,000, you have to pay the $11.95. Or would you pay $3.95 for the basic bank account, 12 free transactions, and free Interact e-transfer transactions per month? Which one would you choose? What about credit cards? Scotia Momentum MasterCard earn 1% cash back on purchases, right? So gas station, grocery, drugstore, and any reoccurring payments that you might have. Low interest rate for the first 6 months, no annual fee. Then your interest rates jump up to 20.99% on purchases. Or the Scene Visa card, 2,500 bonus Scene points with your first $500 spent. The first 3 months, no annual fee, slightly lower interest rate on purchases. Which one would you choose? So hopefully that kind of gets you thinking in the mindset of finance, money, better deals, better options, and just kind of general reasoning why. So a lot of the stuff we look at today probably isn't going to be too difficult in terms of the concepts. It's just going to be more just kind of general reasoning and just at least getting you to think about these ideas and these concepts that you don't think about every day, but it is helpful because you are going to be dealing with finance regardless of what you do. In your life, in your career, you are going to be dealing with finance, money in some form as you go through. So, one last kind of warm up. What do you notice? What do you wonder about looking at this image? Zoom in a bit. What do you notice? What do you wonder? So, looking at some Funko Pops, like little kind of bobbleheads. Looking at the 15 most expensive ones. So we're looking at price. The highest seems to be about $13.3 thousand. The lowest of the 15 anyways is $4.1 thousand. So what do you notice? What do you wonder? Is there anything you notice? Or anything that you wonder? And this is going to more get into kind of the topics we're going to be looking at today. First thing we're going to look at is an asset. So what is an asset? Well, an asset is an item that you own that has value. So if you can think of some things that you have that have value, right? So maybe phones or electronics. You have video game systems, computers, iPads, laptops, TVs, things like that. Those are assets that have value. For some people, maybe clothes. Some clothes have values. Clothes, shoes. Shoes are a big one. Those can be assets to some people. So clothes and shoes. What else? What else do you have that you might have assets? Maybe jewelry. Necklaces, rings, right? Those might have value. So jewelry, maybe a car. If you own a car, or your parents own a car, or your guardians own a car, that's an asset. House could be an asset, right? It has value. Maybe you don't own one, but parents, guardians may have a house, or rent, or you own an apartment or a condo. That has value. Can you think of any other assets? Right? Any other things that you might own that have value? So these are some good examples. Hopefully that allows you to kind of think of some other ones. With assets, there's a couple terms, and these kind of be the main focus. Appreciation. So appreciation is the increase in value of an investment or an asset. But to benefit from appreciation, the asset must be sold. So you can have something that increases in value. Right? Maybe you own a fancy pair of shoes, a pair of Nikes, and they increase in value because you see the price going up online. You only benefit from that if you sell it. Right? If you don't sell it, or if you can't sell it, then that appreciation doesn't mean anything. Right? Let me speak to personal experience, right? Back when I was younger, Pokemon cards. They were really popular. Everyone was trying to get them. Kind of see a resurgence of them now. Maybe not as big as they used to be, but they were quite popular. And it was always told, I was always, I would always like kind of be excited or exclaim about how I had a rare card or I had a holographic card. And the response always was, well, it's only worth something if someone's going to pay that, right? So you can have assets and they can appreciate in value, but it only really matters if you can sell it at that value or if someone's going to buy it at that value. So, of our assets, of the things we own that have value, what appreciates over time? What gains value over time? You can go back to that list that we just kind of talked about, right? So maybe we can think of a house. A house gains value over time. What else? Maybe jewelry, right? Jewelry, gold, silver, diamonds, right? Maybe that those gain value over time. What else can you think of that gains value over time? What causes these assets to appreciate or gain value over time? So maybe rarity, if I can spell that right. So rarity, right? How rare is it? Demand. Is there a demand for these assets? Do a lot of people want this asset that you have? What else? What else can you think of that may cause assets to appreciate over time? Maybe just inflation in general. Things cost more now than they did before. So maybe just inflation in general causes it to increase in value. Exchange rate, maybe, if we're looking at gold, silver, money, different currency, right? Maybe the exchange rate um, causes things to increase over time, right? If some people hold on to American money because they know it's worth more than Canadian money, and they wait till it's appreciates in value and then they sell it, so they gain some more money back off of that. So different things can cause assets to depreciate over time. Again, just one of the ideas that we might think of when we're dealing with some finance. Depreciation is the opposite, right? It the decrease in value of something over time. Right? So something decreases in value. And what assets depreciate over time? So what are some things that depreciate over time? Right? What are some things that lose value? Well, cars tend to be a big one. And yes, there are some cars that appreciate in value, like rare ones, and that goes back to kind of the rare cars that the causes of assets to appreciate, right? The rarity, the reduced supply. If we're talking just general cars that you kind of see on the lot, or a car lot or a dealership, those tend to depreciate over time. Right? Usually, you look at used cars and they're fractions of prices compared to brand new cars. So cars maybe depreciate over time. Electronics depreciate over time. That's a big one, right? Take a look at the newest TV that came out 5 years ago. What is it worth now? Is it still the same? Is it less? Think of new phones, right? What's the original iPhone worth? Maybe in terms of rarity, okay, maybe that appreciates. What about an iPhone 7? We're at an iPhone 14 right now. Is a 7 worth anything? Has it increased in value? So, what causes assets to depreciate over time? What causes assets to lose value? Maybe outdated materials or technology. That's probably a big one. Oversupply, right? There's too much out there then it loses value. Maybe it's used or worn out. Most cars lose value over time because they're being used, right? You're driving the cars. There's kilometers on the vehicle. It loses value. Same with electronics, outdated materials and technology. Plus, if someone uses it a lot, right, who knows how long it's going to last after that. One thing when we're looking at either appreciation or depreciation, if we want to see how the value of something's changed, we usually look at percent change. And percent change is the measure of, or basically measures the change in value over time. So we see, does it increase, does it decrease? If it increased, we consider it like the percent appreciation. If the value is decreasing, it is the percent depreciation. And the formula, relatively straightforward. We take the new value minus the old value, divided by the old value, and then multiplied by 100. So basically we see what is the change, divide it by the old value, and multiply by 100. So kind of like finding out your mark on a test with a small added twist. So let's take a look at an example. So the graph shown compares the depreciation of different vehicles. So the BMW X5, Honda Pilot, Toyota Prius, Subaru Outback. Which vehicle had the highest initial price? Well, relatively straightforward. This one was the BMW X5. That was the highest initial price. How much value did the Honda Pilot lose in the first 5 years? Well, it starts here at about $30,000. 5 years, it is down to about, say, $15,000. You'd say it lost $15,000 in the first 5 years. And what about the last 5 years? So from 15,000 to about maybe 5,000. In this case, it lost $10,000 in the last 5 years. So a little bit of a difference, right? In the first 5 years, it lost more than it did in the last 5 years. We can kind of see that by the graph. It's steeper at the beginning than it is at the end. So you can see how the depreciation of vehicles work. You lose a lot right off the beginning, and then as it gets older and older, it kind of the amount that it depreciates by kind of decreases a bit. Which vehicle lost the most value? Well, I'd say by looking at it, we can see that the BMW started at, say, 57,000 and ended up at 10,000. So it looks like it had the biggest drop, and you can see that by where it starts and where it ends. So even though the BMW X5 had the highest initial cost or the initial value, after 10 years it lost the most. So you would lose kind of the most money if you own that vehicle because it lost the most amount of value. So it went from, say, 57,000 to about 10,000. D, the Subaru Outback had an initial value of approximately $23,000. After 5 years, its value decreased to approximately $12,000. Calculate the percent change. So the percent change, we want to see what percent did it change by, or the percent depreciation, because we can see that it's decreasing. So we're going to take 12,000, the new value, minus 23,000, divided by 23,000, and multiplied by 100. So we go through and we calculate. We end up with negative 47.83%. So the percent change is approximately minus 48%. So it's decreased or it's depreciated by 48%. So it's gone down by it's lost almost half its value over 5 years. We can do the same thing with appreciation, right? Same ideas can apply. We're looking at house prices from 2000 to 2021. We can see that the house prices, or the median or the middle house price in Ontario over time, has increased. So the value of houses has appreciated. So if you own your house, you would have more value available to you because that asset has appreciated. What type of model would be good for this data? What type of model? Would a linear model be good? Could we use a linear relationship to describe this? No, because it doesn't really form a straight line. Right? If we try to model this, if we go back to our data management unit, if I drew a straight line, it wouldn't really work. So it'd have to be something that's almost more curved. Right? So we didn't talk about it too much, but in this case, we would be looking at an exponential model. Which is the same when we think about exponents. That still has the same kind of general idea when we're talking about exponential models. So this would be something where it's increasing drastically, or it's increasing by an inconsistent amount, or the amount that we're increasing by is also increasing. So we want to calculate the percent change going from 2010 to 2022 if we know that the old value, or the original value, was $200,000 and the new value is $810,000. So again, the percent change, the new value minus the old value divided by the old value multiplied by 100. Go through and we calculate it. Again, not a difficult calculation. We just want to make sure that we are doing it correct. So we get 305%. So the value of homes over the last 12 years, based off of this data, has increased by 305%. So the percent appreciation is 305%. So quite a drastic increase in value. Some other types of finance that we're going to look at are types of interest. So here we have simple interest in blue and compound interest in orange. And we're not going to get too much into what each one is. We're just going to kind of look at some generalizations. So we're just going to look at the two graphs and answer a couple questions on them. So if we compare them, what's the same between these two lines and what's different? Well, you might say they both start at $10,000. So in these two terms of investments or interest or savings, they both start at the same amount. They both are recorded for 10 years, so we're looking over the same time span. I wouldn't say there's too much difference between them, or any other similarities. Differences though, compound interest ends up higher. Right, we look at the values, compound interest is higher. You can say simple interest is lower. What else do we notice? Well, you might notice that simple interest looks like a straight line. It looks linear. Compound interest does not look linear. It looks non-linear. Right? It's not increasing by the same amount every time. Actually, what it's increasing by is increasing. That's why we end up with more at the end compared to simple interest. So that there is a difference between compound and simple interest. Essentially, compound interest, you're earning money on top of the money you're already earning. And again, you'll look at that later um, in grade 11, possibly grade 12, depending on what courses you take. But compound interest is one that you most commonly see because, one, when we look at interest rates, banks use compound interest. And when you're saving money, your money is saved using compound interest. And but the percent that you use or that you have is lower compared to the amount of interest that you'd have to pay back if you owned or if you borrowed money. So it works out in the bank's favor because they can charge more when you borrow money and they don't have to pay you back as much when you save money. So it kind of works in their benefit. It does work in your benefit a bit because you do earn more with compound interest when you're saving compared to simple interest, but but you get kind of hit harder when you borrow just because the rates are higher. And we'll look a little bit at that too. Or in the practice questions, you'll see some of that. Using the graph, describe what you think simple interest represents. Well, we kind of mentioned that already. A linear relationship. Compound interest would represent nonlinear. Interpolate at what year compound interest becomes the better option. So at a certain point, they're okay, and then they eventually split off. So I would say it looks like at about a year and a half or a year, if we're going by whole years, looks like 2 years, that's when there tends to be that kind of change. Right? Looks like it starts to deviate. Looks like it starts to deviate a bit earlier, but if we go by the full year, it looks like at 2 years, that's when it's different. Using extrapolation, what would you expect the simple interest investment to be worth in year 15? Well, from 10 to 5, we gained about $7,500. We gained another $7,500 at year 10. So add another $7,500 to year 10. We're at about $32,500. So that is the nice thing about simple interest. It's easy to calculate, but I'd rather have more money than have it be easy to calculate. So what financial decision or decisions can you make using this graph? Definitely say choose compound interest. Definitely choose compound interest because it would earn us more money. Or maybe specifically choose compound interest over the long term. Next example, we're just going to look at the time impact on investments. So here we have 3 different people, Jack, Jill, and Joey, the 3 J's. So they're all investing. They start at different ages, and we see what happens in the end. We see their portfolio value. So if we compare the graphs, what's the same and what's different? Well, the same. They all invest $200 a month. So they're all investing the same amount. They all go to 65 years. So they all end, or at least we're comparing them all at year 65. So they're investing the same amount, and they're going to the same. They're all taking the money out, or we're looking at the value at age 65. What's the difference? Well, big one is when they start investing. So when they start investing is a big one. Jack starts first, so he contributes more than Jill and then Joey. So So by in that sense, they have different values at year 65 or at age 65. Any other differences that you might see between or in the graph? They start investing at different ages, they have different values in the end. Again, you could say contribute different amounts. That kind of goes hand in hand with that they start investing at different times. So, what type of interest are these graphs modeling? Again, is it linear? I would say no. It doesn't look like a straight line. So, you can definitely say nonlinear. And you might say exponential. We did talk about that a bit when we did the graphical modeling. So, I would say exponential. But as long as you can clearly identify that it's nonlinear. So, what financial decisions can you make using this? Well, I would say the big one is start saving early. Right? You may not have $200 a month to invest or to save like this in this scenario, but I would say the biggest thing is just start saving early. Put a little bit aside, put a little bit into account every month, every year, if you have the funds available to you, right? Because we can see if everyone starts saving the same amount at different times, those who started earlier would definitely have um, more value in the end, right? Especially if it's non-linear, right? Because you see that the gap is a lot larger when you start earlier. So again, the big thing from this is just kind of an overview at some financial terms, looking at appreciation, depreciation, percent change when looking at those values, as well as looking at some different factors that could impact or affect investments and savings and different factors there. So again, just kind of an overview, just to kind of get you thinking about finance. Some of it may be common sense, but hopefully at least it gets you thinking about um, some concepts that you'll definitely be seeing in your everyday lives, whether you continue with math or not, because it's just part of the real world and everything that you have to kind of deal with when you start being on your own and dealing with finance. So it is always helpful to kind of learn about it early, or at least to be aware of it early.